Right, next one. 5/6 to the power of -2. 36 over 25. Okay, ladies over there, how confident are you in his answer being correct? Who has confidence in his answer? These three are your fan club. 4, 5, 6. Who thinks it's a load of rubbish what he said? Only one person's brave enough to say that. Okay, let's have a look. Do what we did last time. The minus sign means 1 over. So do it in stages. And then just write the question down again without the minus sign. So we get that. Okay. Now, various ways of thinking about this. That means 1 divided by 5/6 squared. What is 5/6 squared? 5/6 squared is 5 squared over 6 squared. You can take that power there, because all of the numbers in brackets, both of them are, you can put on each one individually. Yeah. So that's 1 divided by 5 squared is 25, and 6 squared is 36. Dividing with fractions. What 3-word phrase did you always remember for dividing fractions? Keep, change, flip. What is 1 times by 36 over 25?
36 over 25.
Yep, he was right. He was right. Okay. So, when you get these, okay, be happy for you, you had confidence in them as well. Okay? When you get these questions, which are quite complicated, do each little bit at a time. Start with getting rid of the minus power by doing a 1 over. Stuff like that, okay? So here's another one. I'm going to freeze this a minute, and then I'm going to do a reveal and see how quickly he can get the answer. So, Callum,
yes.
Are you ready for this challenge?
I'm ready for the challenge.
Right, okay. Here we go. 3, 2, 1.
Plus or minus 5 over 4.
We have a plus or minus 5 over 4. Let's see if he's right. First of all, deal with the minus power. Minus power means 1 over. And then just rewrite the question without the minus power. Sorry, without the minus power, that shouldn't be there. That should not be there. Right, we have here power of a half, which is square rooting. So just change that fraction to be square rooted. 1 over. And if you're square rooting a fraction like this, you can just square root the top and square root the bottom. Now don't panic about what I call these triple-decker fractions. That's fine. Fractions can have 3 bits in. That's not a problem. So that is 1 over. The square root of 16 is 4. Square root of 25 is 5. That means 1 divided by 4/5. Keep, change, flip. Now, let's just have a look. There's one thing I haven't dealt with, and I can't remember now whether you said it or not.
I said plus or minus.
He said plus or minus, yeah. Over here, when you are square rooting, you will have pluses and minuses in. So really, I would say that's where you're doing your square rooting. So from this stage over here, put a plus or minus in. Okay, if you want, it's like in front of the whole thing, but effectively it is a plus or minus over here. Okay, so congratulations, that was correct. Well done. Right, he's not allowed to speak now for the next 10 minutes. We've had enough of him. Right, so next question. Simplify. 2 times 4 to the power of 4 divided by 8 to the power of 3. Simplify that. 2 times 4 to the power of 4 divided by 8 to the power of 3. Now simplify means try and write it down using as little ink as possible, basically. Now, can anybody spot anything about the base numbers? They're different. Okay? Can anybody provide any other comment about the base numbers? And they're written in blue ink is not going to be helpful. So, go on. you can divide them by 2. You can divide 6 by 2, but that wouldn't be so helpful. Try and develop that comment a little bit further. 6 is a multiple of 2, but that doesn't quite cut it here. Patrick?
2 is basically 4 is the square, and the square, 2 squared, and 8 is 2 cubed.
Yeah. These numbers, the base numbers, are all powers of 2. That's the thing to spot. 2 is 2 to the power of 1. 4 is 2 to the power of 2. That is the 4, and I have it to the power of 4. Over here, 8, Gracie, 8 is 2 to the power of... Yeah, because 2 times 2 times 2 is 8. And then that 8 has to be to the power of 3. So if you can spot the base numbers are all powers of something. Now, that's 2 to the power of 1. Here I've got a power to a power. Jack, 2 to the power of 2 to the power of 4.
That's
2 to the power of 8, good. Imogen, 2 to the power of 3 to the power of 3. Good. Okay. Then, when we are timesing, we add the powers. When we're dividing, we take them away. Casey, 2 to the power of 1 times 2 to the power of 8 is... Yep. And I'm dividing that by 2 to the power of 9, so I get 2 to the power of 0, which is 1. Yeah, that was just 1. Okay? So, there we go. That was just 1. Right, next one. Next one we're doing is going to be 27 to the power of 4 times 9 to the power of 2 over 3 cubed. I are working our way around, and I think we're probably with Beth, and Beth is about to tell us in this question that all the base numbers are powers of 3. 27, Beth, is 3 to the power of 3. So that 27 is to the power of 4. 9, Beth, is, so that 9 is to the power of 2. On the bottom, I can just leave that as 3 to the power of 3. So, Beth, 3 to the power of 3 to the power of 4. Yep. 3 squared. Squared? And I'm dividing that by 3 to the power of 3. Do you want to just tell us what that is going to be? Yeah, that's right. 3 to the power of 13. Okay. Right, next one. We're going to simplify ALB to the minus 2 over L cubed divided by A cubed L over B to the minus 2. Do you think it was somebody fairly sadistic that made this question up? I think this has actually come from the book, and it was one people were stuck on last year when I did it, so I made a note to do this one. There are various ways we can start on this. What were you going to say?
So would you start by keep, change, flip?
Could do. You could do. You're doing fractions here. You're doing divide. Suggestion is keep, change, flip. Okay, there's nothing wrong with doing that. That's fine. Timesing fractions is always easier than dividing. Absolutely fine. Right, so what do you think it would be good to do next? What's making it nasty?
There's no numbers.
There's no numbers.
And they're all
Math isn't about numbers. Math is about what you do to things.
The base numbers aren't the same.
The base numbers aren't the same. What else is making it nasty?
You've got fractions.
Yeah, the fractions and the minus powers. I will deal with the minus powers next. So I'm going to put my 2 fractions down here. If it has not got a minus power on it, I'm just going to write it in where it is at the moment. So those are the bits which did not have minus powers on them. What does a minus power do? 1 over. Effectively, if it was on the top, it puts it on the bottom. But equally, if it was on the bottom, it would put it on the top. So here, the b to the minus 2, I would just drop the minus power and put the b to the 2 on the bottom. We can do the same thing over here. In fact, it's got a minus, so I'll just put it on the bottom without the minus.
Put a 1 on top.
Yes. Where there's a gap, you do need to put a 1. Right, now, go on. You're not allowed to talk, 'cause there's another 3 minutes yet where you're not talking. Right, okay, let's have a look. Over here, on the one on the left, I've got an a on the top, there's no a on the bottom. I've got a b squared on the bottom, there's no b's on the top, so there's no cancelling involved there. But I've got an l on the top and l cubed on the bottom. What will that lead to?
L minus 2.
L minus 2. I don't want to write minuses, they look nasty.
Oh, right.
You're right, but I don't want to write a minus. I got rid of minus signs.
Why don't you just put like 1 on L squared?
Where?
I don't know. Just stick it somewhere.
No, where? The minus power, you were right. When you said L to the minus 2, you were right. A minus power means stick it on the bottom, yeah. Okay, so there we go. That's the first bit.
Terrible line.
Right, over here, well, there's nothing much I can do there. There's nothing on the top and the bottom, because there's nothing really on the top. So, times the tops together, a times 1 is a. Times the bottoms together, look at it letter by letter. A's, there's just a cubed. B, there's a b squared times a b squared. What will that give me? b4. L's, there's an l squared times by an l. L3 or l cubed. Finally, there's an a on the top and there's a cubed on the bottom. So I'm going to write everything else in other than the a's. An a on the top and an a cubed on the bottom leaves me with a squared on the bottom. I'm not allowed to write nothing on the top. Put a 1 in. There we go. Okay, right, moving on. We're going to solve an equation now. Now this does go, I think, beyond GCSE.
Moving on to AS.
Although, I reckon you guys probably have an idea of where to start. Can I get rid of the top bit of the board? Okay. So, folks, we have dealt with something similar to this, and how we dealt with it before, we are going to deal with it now. So, either Emma, Olivia, Charlotte, Patrick, or Tristan, what is there to spot here? Patrick.
The x plus 1 and x plus 2, which was divided, which would suggest that the answer would be like x minus 1, but instead it's x plus 3. So that's...
Okay, don't worry. That wasn't what I was looking for. I'm not saying it's wrong. It wasn't what I was looking for. Okay, I'm still sticking with that table over there. Go on.
Are all the base numbers? Yeah.
Yeah. All the base numbers.
Callum and I.
All the base numbers are powers of 2. Are you now Callum's sort of mouthpiece instead?
Yeah.
Right, yeah. 2's something to the 2 is 2 to the power of something. 4 is 2 to the power of something. 8 is 2 to the power of something, like we had before. So I'm going to rewrite that 4 as 2 squared, and then put the power on it. I'm going to rewrite that 8 as 2 cubed, and then put that power on it. Then I'm going to get rid of my brackets. Now be careful here. 2 squared to the power of x plus 2. 2 to the 2x plus 4 is correct, yeah, okay. You're timesing 2 lots of x plus 2 is 2x plus 4. Over here, you're timesing the 3 by the power. I think it's time we heard from Heidi. Heidi, what power am I going to write on this 2 here? Yep, that's right. Good. Okay. So, now, let's do the left-hand side. Let's just work on this bit here. 2 to the power something divided by 2 to the power something is 2 to the first power take away the second power. Because when we're dividing, we do taking aways with the powers. I think we are coming around to Lucy. If you're brave enough, Lucy. I need to know the answer to that. Take away that.
X minus 3? No, minus X.
Correct. Minus x, because x take away 2x is negative x. Positive 1, take away positive 4, minus 3. Okay. And on the right hand side, I've got that. Now, I've got something to a power equals the same something to a power. What do you think I can do at this point?
Could you? Wait.
Go for it, just try it.
Could you like times it?
No. Right, okay, I'm not saying it's not the best way forward anyway. You're still barred for another 30 seconds. Go on.
Could you like just take the powers out of the two? And
Yeah.
like, set them to
As long as these two things are the same, what you've got here is basically something to a power, and then over here you've got the same, bit of a challenge, the same thing to another power. You can just say the powers are equal to each other. I'm going to scrub that line out. Okay? But basically we can say here that negative x minus 3 is going to be the same as 3x plus 9. But that's only because the base numbers were the same. Only due to base is being identical. And that couldn't have happened if there had been a sort of sum or anything between them. We couldn't have done it at this stage here. Couldn't have done it at that stage. It's got to be simply base to power equals same base to power. This one had a dividing thing between bases. It wouldn't have worked at that stage. So, we are here. What are we going to do to solve this equation? Yeah, take the x over here, the minus 1 over the other side. So keep that minus 3 there. Bring that plus 9 across. I reckon that's minus 12 equals 4x. So x equals? Minus 3. Okay, there we go. Now, in the exam, do you now move on to the next question?
No.
Why not?
Because you still got
I would, at this stage, that is your final answer, but I would just go back and check. Now, I am going to have to zoom out a bit here to get the whole thing on the board. But let's just check. That top line was 2 to the power of x plus 1 divided by 4 to the power of x plus 2 equals 8 to the power of x plus 3. If you just substitute that back in the question, that is what we will get. So this, it is worth just checking. Is this true? This is 2 to the power of minus 3 plus 1 is?
2. No, minus 2.
Minus 2. Okay.
Sorry.
2 to the minus 2 is 1 over 2 squared. 2 squared is 4. So that's a quarter.
Am I allowed to speak now?
You're allowed to speak now, yes. Okay. Over here, minus 3 plus 2 is minus 1. 4 to the minus 1 is 1 over 4. Over here, minus 3 plus 3, 0. Anything to the power of 0 is 1 quarter divided by 1 quarter 1.
Yes.
Then in the exam, you rub it in the nose of the examiner and you put a smiley face there because you know you got it right. Okay? No, seriously, do the checking. When you can check an answer, check it. And here, you could check the answer, so do it in the exam. Right, that video's gone for 19 minutes. Time to start another one.